Earlier, you were talking about, I want to make sure I heard this correctly because I can't get out of my head. Something about dark comets or something earlier. Are you saying that we have seen stuff that could be a spaceship out there that we've detected or we're just not sure or what? What did I hear?
Well, so the astronomers who talk about it, they found the 14 objects that are being moved around by some unknown force. And they say it's a dark comet because they say that the only force they can think about is cometary evaporation. And it's just possible that we don't see the gases coming out of the comet because the force is relatively weak. It's not a very strong force. And they say maybe, we just can't see the tail.
Got it.
But of course, that's what you would say about some technological space trash, that happens to be pushed by reflecting sunlight or has some or has some propulsion of its own. And we don't know much about these objects except that there is some force acting on them. So that's one example. But then there are objects near Earth, many of them that are called empty trash bag objects.
Yeah.
And they are thought to be broken pieces of satellites, but people just don't study them in great detail. And that's on top of the unidentified anomalous phenomena that the US government talks about, that the military reports about, and that the Galileo Project, the observatories that we're building are attempting to detect.
Are you guys working on any of these? Like, how far out is the Galileo Project looking at? What's the scope here?
First, I should say the observatories that we are building are very different from traditional astronomical observatories, because in astronomy, very often the telescope looks at a very small part of the sky at any given time.
Okay.
And focusing on distant sources. And what we are doing is looking at the entire sky all the time, and especially focusing on things that fly overhead, that are close to Earth. And within the atmosphere of the Earth, we can see out to about 5 kilometers or so with our infrared cameras. And we also have a visible band camera and a radio sensor and an audio sensor. And then every month we collect data from each observatory. We collect about 100,000 objects in the sky, and we are analyzing it with machine learning tools, trying to see if there is anything that is not familiar, not a airplane, balloon, drone, bird, satellites. And so far we do not have distance information because we just have data from one site. But in the coming months, we hope to have multiple units within each observatory that look at the same object from different directions. If they're separated by a few miles, they can do that, and that will tell us the distance. That's called triangulation. And so we have one observatory operating at Harvard University. We have 2 more that should be completed by this summer 2025. And another one that will be constructed a year or 2 later. And so altogether, we hope to have 4 observatories that monitor the entire sky in 4 locations, one in Massachusetts, another one in Pennsylvania, a third one in Nevada, and the 4th one in Indiana. And that should give us a few million objects every year. And even if 1 in a million of the objects that we monitor happens to be of extraterrestrial origin, that would be a huge breakthrough in science. Now, the government, they established, as a result of the reports from the Office of the Director of National Intelligence, they established an office in the Pentagon called the All Domain Anomaly Resolution Office.
ARROW, right?
ARROW, and they just are happy if they identify 97% of the objects. For them, it's great success. But from a scientific point of view, not knowing what a few percent of the objects are is not really satisfactory. Yeah, and because obviously in the sky you have a mixed bag. Most of the objects would be human made.
Sure. I mean, yeah, or animal. I mean, so we're talking. There must be millions of things flying around every day. I mean, how many
Right.
things are up in the sky all the is it in the
Yeah.
millions, you think? I mean, my
Well, it
God.
depends. It depends what you count, but
Sure.
we, yeah, I mean, I would say, and it depends on over which region of the Earth you're talking about. But
Just all the earth. If we were to like estimate on a daily basis how many things are, lit
mhm,
off the ground, flying around, whatever, a bird, balloon, a plane, a drone, an UAP. I don't know. I mean, are we talking millions across the globe every day up in the sky?
I would
I guess,
say
right?
even more than that. I would say
Probably,
perhaps
yeah.
even a billion if you count
You
everything.
count birds, right? Especially
Well, if you
birds, right?
include yeah, exactly. So I would say a billion or more.
I mean, that's
Uh,
crazy. That's
yeah, it's
so
crazy.
many. That and 3% of that is a
Yes,
lot.
exactly.
So I'm with you.
So
Yeah, that's
and also
crazy.
they don't have distance measurements for those, so they don't know how fast they actually move,
Yeah,
how much they are. So what we are trying to do is bring a scientific rigor into this and get very high quality data. Already we published a paper about 500,000 objects that we analyzed. This was never done before, and we are now entering a new phase where we are analyzing a lot of data. And my hope is that in the coming year or two we will have something interesting to report about. I mean, I tell my team that if
yeah,
it's all about statistics, so that we have hundreds of thousands of objects, and we split them into drones, into birds, into airplanes, and so forth. That is not an interesting, exciting paper. If we find one object, just one object that is behaving in a crazy way, that would deserve a paper by itself, and that would be the most exciting result, as far as I'm concerned.
like let's say you did this for 10 years and year after year you don't really find anything anomalous. Would that tell you there's nothing flying around our skies that's actually anonymous, or
Well, it
what
would.
would you think?
You can translate any such data to an upper limit, basically saying there is less than one object per kilometer squared on Earth per year or per 10 years that is anomalous or not identified. Then you can keep pushing the constraint down. It's not clear if we are visited. It's not clear over which period of time would you detect the first one, and how
Yeah,
frequently it is and how abundant it is. And so it's like any other search in science. You if you don't find anything, you just put limits. And the
sure.
question of how long you should do it is really a matter of taste. For example, we had a lecture at a conference that I organized by an experimentalist that is searching for the nature of dark matter. So he is searching for specific types of particles, and basically he invested maybe up to $1 billion by now in detectors for the specific type of particles, weakly interacting massive particles. And he was pushing down the limits on the interaction rate or cross section. And I asked him, how long will you continue? I mean, you already pushed it by orders of magnitude, and he did that for a couple of decades now. And I said, how much longer will you continue? When will you stop? And he said, as long as I'm funded. But that just shows you, I mean, people are doing that. Scientists are doing that for
Sure.
decades. I'm just saying we haven't done that. And
Yeah.
we should do it at least for a decade before we argue that there is nothing.